Okay, so what have you seen here? What about the twigs? Are they alternate?
Opposite.
Or opposite? They're opposite.
But there are two at the same place, but opposite.
Yes.
I don't know how to describe
here.
it.
Have a look here. You see there? Two twigs coming from the same place. And there, two twigs coming from the same place. Now, where you see that there's only one twig coming out, if you look at the other side, that it's broken. There used to be a twig there. And so it's very definitely an opposite pattern. And here, this is last year's growth. There are no twigs coming off it, but there are buds. And you see the buds are very much in pairs. So this is opposite. There are not many British trees which have opposite buds. There's a few shrubs, but there's really only 3 common trees, and this is one of them. What about leaves? Anyone found any leaves on the ground? Does that leaf remind you of the flag of any country?
Canada.
Canada, yes. So it's a maple. Well, it's not a Canadian maple. It's a native maple, known as the field maple, and that's simply because the Latin name is Acer campestris. Field maple is a bit of a misnomer because it's much more often found in the woods in this country. So Linnaeus must have given it the name the field maple, for that perhaps it mainly grows in the open in Sweden, which is where he came from, and so people have just simply translated the Latin name. It's a common woodland tree, one of the commonest trees in semi-natural woodland, along with ash and hazel. It's a great generalisation, but given over most of lowland England, that tends to be the case. We might also find some of its fruits. See if you can find any fruits. Ali has got some fruits in his hand.
There's some still in the tree. Oh, yeah, that's seeds.
Uh-huh. Yeah, now there's one. See that? You know the sycamore? The sycamore is also a maple, but it's not a native tree. It's a naturalised one, which means it was introduced by people, but has established itself and reproduces without any help from us. So this is related to the sycamore. They're both
Acer.
acers. Yeah.
What's the sycamore?
Acer pseudoplatanus.
Oh yeah. Pseudo.
Yes.
And how do you differentiate?
Well, the leaves of the native maple are much smaller. The bark is furrowed, which it rarely is in the sycamore. Now, if we had 2 of these little seeds, or fruits as they're more properly called, the seed is just a little bit inside. Right, okay, if we had found these together, they would be joined together like that, in a straight line with each other. Whereas if it was a sycamore, they'd join together at an angle of 90 degrees. And these are what you call helicopters, because you throw them up in the air and they fly away like little helicopters. Now, this is a really good example of what I was saying earlier on. I was saying it with respect to leaves, but now in this case it's true also with respect to fruits, because this comes from a different tree. A tree that we'll be having a look at next, just over there. And so I'm not going to tell you which tree it is, because we'll have the same game of asking you to work it out. But that has been blown over here or come here by some other means, and although we found it underneath these maples, native maples, it's not maple fruit. Now, okay, that's the identification bit done, but quite an interesting question to ask is, why are these 2 trees such different sizes? Do you think the big one is older than the smaller one?
Maybe the wind.
Let's just establish whether we think the big one is older than the smaller one.
When you say big one, you mean the taller one?
Yeah.
The size.
Light.
That's a good point that Massimo has made. Actually, there's not that much difference in the diameter of the lower trunk. And that's a bit of a clue, but actually that one is a bit smaller. but you can see it's got so much less leaf area to build up new wood. But it used to. You see, it's suffering, that tree. I mean, having seen these trees over a period of, what, 15 or more years, the difference in size has become exaggerated over that time. As the one on the right has grown, the one on the left has actually, if anything, got a bit smaller as it's died back. But what caused the... I mean, obviously, competition is now affecting it. The big one is crowding out the little one. But why do you think the difference started? You know, what initially made this one grow less well than this one?
This one was the bigger one is a healthier gene.
Light.
I doubt there's a significant genetic difference, although you couldn't rule that out. Light, well, that's more or less south. South is about there. So there's probably not a great difference in shading.
Maybe there was predation at some stage?
Predation?
Predation at some stage with the tree that's not growing quite so well.
Uh-huh. Any idea what kind of predation it might be?
Rabbit.
No, rabbits mainly get them when they're little. Once they've got beyond that infancy, they're probably all right from rabbits.
Imagine it would have been deer.
Cattle have got something to do with it. It took me quite a few years actually before the penny dropped and I realised what had been going on here. There's a gate just next to us. And when there are cattle in these fields, they walk through that gate and they make a great track going down the hill like that, and they wear away all the soil. And so the soil in the root area of this tree becomes compacted because it's closer to the gate. This one is further away from the gate. It's not nearly so much affected by soil compaction. So, you know, this is a wonderful object lesson in the importance of soil structure. So, here we have two large trees, and every year it gets a little bit more difficult to grab hold of a twig because there are horses usually in this field. And yeah, actually it's not too difficult because they sort of reach up and browse, so you get quite a high browse line. Now, this is quite an interesting one. Come closer. Look at the colour of the bark. What colour is the bark?
Gray.
What colour are the buds?
Black.
Black. And that is very characteristic pattern of the ash tree. This is the ash tree. Now, it's quite difficult to see here, but see if you can work out whether it branches opposite or alternate. It's a bit difficult because this branch has been in the wars a bit.
Opposite.
Yeah. I mean, the thing is, if you can see any twigs opposite, it's pretty well certainly an opposite branching species. Because with an alternate one, you'll never get two twigs opposite. Whereas with an opposite branching one, some of those branches may have died.
Yeah.
Okay. Now, so it's the ash. It has a very characteristic leaf as well in the summertime, which of course we can't see at the moment. And you see those fruits hanging down?
Yeah.
Those are the ash keys, which Ali found an example of way over there. So if you really want to know something belongs to a certain tree, it's much better if it's attached.
So they are fruits, not leaves. Right?
Exactly, they're the fruits. And ash is one of those trees where sometimes you get both on the same tree. That's called hermaphrodite. No, it's not, it's called monoecious. It's when they're both in the same flower that you call it hermaphrodite. When they're both on the same tree, you call it monoecious, and when you get the male flowers on one tree and the female flowers on another, that's called dioecious. And ash is a mishmash of both. Some trees are predominantly male, some are predominantly female, and some are a mixture of the two. Anyway, you don't need to remember all these words.
So these are fruits. So
Yeah, so you know that this is either a female tree or a mixture, but you don't know whether it has male flowers because it's the wrong time of year. You have to wait till April to see that. Again, it's wind-pollinated tree, so it tends to flower before the leaves come out early in the season. Now, another interesting thing to look at is the bark. You remember what the oak bark looked like, and see the bark of the ash tree. How would you characterise the difference between the two?
Small weedy.
Yeah, it's a much less pronounced furrow.
Yeah.
It's a much smoother bark. They're both furrowed, but there's a definite difference. Now, there's a lot of variation between different ash trees, but in general they're much more smoothly barked than oak. Still furrowed, but a gentler, softer furrow. Okay, let's just walk back a bit up the hill and have a general look at these two trees. I just asked people what they could say about the shape of the tree, and the answer came in, they're multi-stemmed. I said, what does that signify? And they said that they've been coppiced in the past. Another thing to look at is the branching habit. You know, where do the first branches come? And this is similar to what we saw with the oak tree. You know, you've got a relatively short stem there, and then they start branching. Particularly on that one on the left, it's very pronounced. So just bear that visual image in mind as we go into the wood, and in there we'll see some more ash trees. Remember what those ash trees looked like outside in the open in the hedgerow? Well, most of the trees in here are ash, or at least a good half of them. And just look at the difference in shape. So if you're looking at trees for their general shape, to try and identify them by shape, you need to remember that actually the conditions that they're growing in have much more effect on the shape than the species does. All the trees in here are drawn up to get to the light, and all the ones we saw in the hedgerow have got very short trunks and branches coming out low down. So that's something to remember. And here, any idea what this might be? Have to look up. Anyone willing to hazard a guess? Risk ridicule? I tell you, there's more ridicule in not guessing what it is. Yeah.
There's the keys up there, are they?
It's ash, yeah. The key, you can see there's keys. And also this, which appears to be growing out the root of it, you can actually get a close up at the twigs. Now, one interesting thing here is, you see how smooth this small diameter branch is? Very smooth grey bark. Compare that with this mature trunk, which is furrowed. That's very typical of almost all trees, but particularly of ash. That it starts out smooth, then it gets a little bit thicker, and it begins to get a little bit furrowed, and then as it gets older it gets more furrowed. And you'll see differences between different individual ash trees of the same age, and that's a genetic difference. But if you look at the different branches on the same tree, you'll see how it develops through time. Okay, now let's just have a look at another tree. That one over there, next to the bendy one.